All right, so we will go ahead and get started this morning. We are going to pick up sort of where we left off a couple of days ago, and we're going to talk about percent composition. We're just going to review that, or I think in you guys' case, this will be some first instruction. So we're going to review something called percent composition. And here's what I want to ask you guys. If I have the molecule H2O, all right, we all recognize that? Yeah, H2O, that is also known as water. Excellent. Okay. And if I said, what percent by mass is hydrogen what percent by mass is hydrogen of an H2O molecule? All right, so what we're asking is what percentage of H2O is made up of hydrogen? What would you say? Yeah, a lot of people look at that and they say, hey, there are two hydrogens and that implied one oxygen. And so people say, hey, there are three atoms in water. Two of those are hydrogen, so clearly it must be, 67%. That is true in terms of numbers. Here's the thing. Yeah, but it's definitely not true by mass because, you guys remember, oxygen has so much more mass than hydrogen does. What's the mass of oxygen? Look on your periodic table.
15.999.
Yeah, 15.999. So if we rounded to one spot, or excuse me, to a whole number, we would say that oxygen is 16, hydrogen is 1. So literally the oxygens are 16 times as massive as the oxygen, or excuse me, the oxygen is 16 times as massive as the hydrogen is. Okay, so we can't just look at the numbers of molecules. That is not going to be okay for us. All right, what we're going to do instead is we're going to arrange it by mass. Now, I'm going to look at, and I'm going to switch colors because I don't think the red's showing up very well for you guys on that. All right, so let's see. Just erase that real quick. Oh, I said erase. There we go. All right, everything's got to get its act together this morning. All right, so I look at H2O. Now, I have two hydrogens. Each hydrogen, I have two of them, and each one has a mass of, how much did we say? 1. Excellent. Okay. So what's going to be the total mass of hydrogen? Yeah, 2 AMUs. Very good. Okay, 2 atomic mass units. Now, oxygen. I only have one of them. Okay, you guys are bright. I don't need to put the 1 here. And how much did we say that its mass was?
16.
Yeah, 16 AMUs. So 1 times 16 is going to be 16 AMUs, all right, atomic mass units. Now, so what we're going to do then is I'm going to just add that together, and then for H2O, the total mass is 18 atomic mass units. Yeah? All right. Here's the thing. Here's what we're going to run into. Let's see. Now, you know that any percentage is part divided by whole. I want you to write that down in your notes. Percentage equals part divided by whole times 100. Okay? Here, I'll write it so that we'll all... Whoops. So we know that the percentage is the part divided by the whole. Oh my gosh, my handwriting not so much today. Times 100. All right? So if we want to find a percentage, it's going to be the part divided by the whole and multiplied by 100. Now, I wanted to know the percentage of hydrogen. And again, we're talking about by mass, which is why I'm working with these masses. All right? So the percentage of hydrogen is the part of hydrogen. How much of this molecule is hydrogen? What did I say its part was? 2. So 2 AMUs divided by what is the whole mass of water?
18.
The 18. Excellent. Excellent. All right. So the percentage of hydrogen is going to be 2 divided by 18 times 100. Now I want you to, everybody on your calculator, hit 2 divided by 18. And I want you to see what it tells you. Okay, it gave you a decimal. Did anyone's give them just the fraction 1/9? Okay, if it does that, that's just the mode that it's in. If you'll hit Control and hit Enter again, it will give you the decimal. All right, so if it gives you a fraction, just hit Control, Enter, and that will put it in the decimal for you. All right, so then multiply that by 100, and we're going to get that the percent hydrogen is 11.1% at 3 significant figures. All right, we feel good about that? Excellent. Now, again, there's a couple of ways that we could find then the percent oxygen. Okay, so the percent, first of all, I'll just come up here and answer this question. Percent mass of hydrogen, we said that that was 11.1%. How's the blue showing up for us? That's showing up okay? Yeah, sort of. All right, so 11.1% for that. Now, if I wanted to know the percent of oxygen, there's 2 ways I can find it. What's one of those? All right. The water molecule is made up of hydrogen and oxygen. The hydrogen is 11%.
Oh, 100 minus 11.
Yeah. So the oxygen would be 100 minus 11.1. We could find it that way. Hey, I don't want to do that though, because what if I got my 11.1 wrong? Then I would mess up my other one. So I want to check it by actually calculating it. All right. So what we're going to do is now we're going to now instead of the percent hydrogen, we're going to do the percent oxygen. All right. Hey, how do I do a percent? Part over whole. Hey, somebody from my far side. What's the part that is oxygen? 16. Excellent. Okay. So my part that's oxygen is 16 over 18, because 18 is still the whole amount. Punch that on your calculator and see what you get, and multiply by 100. Now I want you to look at what's past the 8 and see if it needs to round up or down. All right, so it's going to be 88.9%. So the percent oxygen is going to be 88.9. All right. Hey, do we feel good about that? All right. Let's do one more for practice. All right. I'm gonna pick a harder one. I would like to know, and go back to my green because everyone loves green. Why does everyone love green? Because I went to Baylor, so everyone loves green. What percent, except right now, Baylor is not playing football because COVID. They had to shut everything down for a little while. Hopefully they'll get back soon. So they're having homecoming this weekend with no football game. I know. How does that even happen? Is it even homecoming? I don't think so. Hey, what percent of And let's see, I'm just going to say what percentage of sodium chlorate, no, not, yeah, chlorate. What percent of sodium chlorate by mass is carbon? Oh. Never mind, change that carbon to chlorine. I was going back and forth in my head between saying carbonate and chlorate, and clearly I have messed it up. All right, is chlorine. Ooh. All right. What percentage of sodium chlorate by mass is chlorine? All right. Now, here's the problem. The first thing we need to do is we need to look at the atoms and see, see the numbers of atoms and calculate their individual masses and weights. Sodium chlorate. What's the chemical formula for that? All right. Hey, somebody on the far side. Good.
I'm not sure, but I think it's
NaClO3. Is chlorate a -1? And sodium's a +1? So those are a perfect match. Hey, you're correct, sir. Good job. All right, way to go. So, sodium chlorate is, in fact, this molecule right here. So let's look up sodium. There's only one sodium, so we can just look it up straight off the periodic table. What is its mass?
11. Wait, no, never mind. 23. Or 22. There's someone
Okay, so which one? Which one's it going to round to?
23. 23.
All right, 23. All right, so sodium is 23, and it technically is AMUs, so I'm going to write that down. Next, chlorine. 35.5.
Yeah.
So it needs to round up to 36?
No, it's 35.
Or is it 35.4? All right. Hey, let's just look at the number. It says 35.45, so we're going to round down. We're not going to do the double round. That'll get you in trouble. All right. And then oxygen is going to be 3 times... Hey, why did I put a 3? Yeah, because I've got 3 of these, which is why I put that 3 there. All right? 3 times, what is the mass of oxygen? 16. So what's 3 times 16?
48.
All right, 48 AMU. All right, so we got that. Now that means that, so there's my individual parts. What's my whole molar mass or molecular mass? Okay, the molecular formula weight of this is going to be, you add that up, 23 plus 35 plus 48, and got what? 106? 106 AMUs? All right. So this wanted to know then about the mass of, the mass of chlorine, okay? And so it wants to know about the mass of chlorine. So I'm just going to say, all right, percentage of chlorine is, and what's my part of chlorine? 35. Whole? 106. Carly, you agree? All right. Carly, punch the numbers and tell me what you get. And then we're going to multiply by 100 to turn it into a percent. $43, you said? $33. Hey, is there a decimal? Give me the first decimal place. 33.0, and even rounding, it's still 0?
Yeah,
Okay. So 33.0%. Good job. Anybody else get that also? We have a confirmation? Excellent. Excellent. All right. Hey, that is the basics of how we work through percent mass and finding percentage by mass. All right. Next question. Now we talked the other day about moles. All right. And so we talked about that a mole is a counting number. You should already have this in your notes. You don't necessarily have to write this down. A mole is a counting number. And we talked about that 1 mole is equal to 6.02 times 10 to the 23rd of something. Okay? And we also talked about that if I had 1 mole of a particular element, that was equal to the number of grams. That was going to be in grams what its atomic mass is in AMUs. Okay, so for example, 1 mole of chlorine atoms was going to be 35 grams. And 1 mole of nitrogen atoms was going to be, what's the atomic mass of nitrogen? 14. Excellent. 14 grams. And then 1 mole of, somebody pick a favorite element.
Gold.
What?
Gold.
Gold. All right. I like it. All right. Hey, 1 mole of gold is, find it and tell me. 197 grams. Now here's what I want you guys to remember. All of those, okay, 1 mole of chlorine is 35 grams, 1 mole of nitrogen is 14 grams, 1 mole of gold is 197 grams, but all of those contain 6.02 times 10 to the 23rd atoms or particles. Yeah? We're good there? Okay. Let's see. Ooh, front row. I remember I said your name wrong. So Tanya, right? Maybe? No. I'm making stuff up now. All right. That must be second period. Sorry. Tell me your name. Natalie. Yeah, that's not even close to, that's not even close. All right. Natalie, welcome to class. Hey, does that make sense that, that even though each of these has a different weight or a different mass, that they all still have this many particles because they're all different sizes, right? Okay. We all know that gold is a bigger atom than nitrogen. It's got more protons, got more neutrons. It's just bigger. All right. And so it makes sense that this many of it would have a different mass. All right. And so that's that. And we did some practice on 2 days ago, on Tuesday, of if I gave you the number of grams, you could tell me how many moles. And if I gave you the number of moles, you could tell me how many grams. All right? Did we do some practice with that? Okay. And then we also looked at, hey, if you have this many particles, you can tell me how many moles. And if you have this many moles, you can tell me how many particles. Right? And so we did that also. Here's the thing. What if I ask you, so I've got a new question today. Let's see, and I'll hit it in yellow. All right, I'm going to just kind of close all this off. All right. So my question is, if you have, go ahead and start writing down this question. Let's see, 412 grams of calcium how many particles do you have? All right, and so the question is, if you've got that many, if you've got 412 grams of calcium, how many particles of calcium do you have? All right, and here's what I want us to look at. You can switch from, get all that off there. All right. You can switch from grams to moles and moles to grams, or you can switch from particles to moles and moles to particles. This is giving you what? This gives you grams, and it wants you to go to what? Yeah, it wants you to go to particles. How many particles? Okay. Hey, you cannot make that trip in one step. Okay? And here's why. Because all the particles are different sizes. Okay? And since all the particles are different sizes, just because, like if I said we had 197 grams of gold, that's only 1 mole of particles. That's 6.02 times 10 to the 23rd. But if we had 197 grams of helium, hey, that's way more, because that's a lot more moles of helium. Do you see how we cannot make that trip in one step? Okay, so here's what you always have to do. You always have to go from grams to moles and then to particles. Or you can go backwards and go the other way. Particles to moles to grams. But no matter what, you always have to go to moles first. All right? So we're always going to go to moles first. All right. You guys remember my little setup that I did like this? I'm going to start with what I'm given, 412 grams of calcium. Now, remember, the first thing that I need to do with this is I need to change it to moles on my way to particles. So I really want particles, but on the way I'm going to go through the mole conversion. All right? Hey, I've got grams of calcium up here, which means I need to put grams of calcium down there. How many grams of calcium is in 1 mole of calcium? Look on your periodic chart. Everybody look and everybody decide.
40.
All right, we all coming away with 40? How did we know that? It is the atomic mass of calcium, which means that 40 grams of calcium will be 1 mole. All right, so now when I take that 412, if I divide it by 40, then I would have moles. Hey, here's the thing though. I've decided I'm going to go ahead and put another step on here, and I'm just going to do it all in one math problem. Okay? This is why I like to set up the grid. Now, you could go ahead and convert to moles and then set up a second problem to go from moles to particles, but I'm going to do it all in one big grid. All right. Hey, here we go. Now, I want to go to particles, but that means I need to get rid of, okay, now I already got rid of my grams of calcium, so I'm going to cross them out. All right, next thing I need to get rid of is my, let's see, switch to this, moles of calcium, which means I need to put 1 mole on the opposite side. All right, and then that's going to go away. Ooh, what is 1 mole of calcium equal to in terms of particles? Hey, what's 1 mole always equal to in particles? 1 mole is always equal to 6.02 times 10 to the 23rd, right? That's how much a mole is. So 1 mole is going to be 6.02 times 10 to the 23rd particles of calcium. All right? So at this point, and I'm gonna do a little selecting for us here. So I'm going to end up doing this. I'm going to end up with 412. Everybody see that? I've got 412 times 1. Okay, you don't really have to put that part in your calculator. I just wanted you to see it. Times 6.02 times 10 to the 23rd. And all that's going to be divided by 40 times 1. All right? Hey, type that in your calculator and let me know what you get, okay? Actually, everybody type that in your calculator and nobody say it out loud right now. Everybody think but don't speak. And I'm going to type it in my calculator as well. All right, 412. Oops, I typed it backwards. Be sure you don't type it backwards. 412. And then I'm not going to put times 1. I'm going to put times 6.02 times 10 to the 23rd. Then I'm going to take that answer and I'm going to divide by 40. And at 3 decimal places, I'm getting whoops, I wrote that wrong. That's going to be 6.20 times 10 to the 24th particles. Tell me again. Oh, well, I told you I wanted you to type it in your calculator and then think about it and not say it out loud. But now it's time to say it out loud and check our answer.
Yeah, but you said it.
Okay, yeah, so I messed that up, sorry. Hey, is that what you got?
Yeah.
No.
I said yeah.
Oh, yeah. Okay, good. Good, that makes me happy. All right. Are there any questions about how we got that? All right. Let's see. Let's do one more going from particles back to grams, just for fun. All right, particles back to grams. So let's just say that I have I don't know. Let's just say 5.00 times 10 to the 26th. Let's say that I have that many particles of, and I'm going to do particles of a compound this time. I'm going to say barium chloride. Okay. So I've got that many particles of barium chloride. And I want to know how many grams is that? All right, how many grams is that? Now, so what I'm going to do is I'm going to write down first of all, I'm going to put my big long, working line. and I'm going to put 5.00 times 10 to the 26th particles of barium chloride. Hey, what did I tell you the first step was going to be always? First step. What's the first step? Always. Okay, we write down what we started with. When we're going from particles to grams, first step is always to go to moles. You always have to go to moles in between. All right? So, how many particles of BaCl2 are in 1 mole of BaCl2? I'll give you a hint. Hey, how many particles are always in a mole? Yes, Avogadro's number, 6.02 times 10 to the 23rd. So we will end up dividing by that. I'm not going to do it yet, though. My particles will go away. And so I'll be left with moles of barium chloride. Well, that was not my finishing point, so I need to get to the finish. I'm going to stretch my line out a little more, even though it looks a little messed up. All right. Hey, I need to get rid of moles, so I'm going to write 1 mole BaCl2. Ooh, here's the tricky part. How many grams are in 1 mole of barium chloride? Does anybody know? How can we find out? For calcium, what did we do? We just looked on the periodic table, right? Barium chloride is not on the periodic table. Or is it? It's there, but it's in pieces. All right, so I got, somebody has already done the math. Good. Hey, 1 barium, because in BaCl2 I've got 1 barium. How much is that? 137, okay. And I've got 2 chlorines. And that's 35 times 2, so that's 70. Ooh, I'm quick with this math. 207. All right, which means that my final math problem is going to be this number times 207 and then divided by Avogadro's number. All right? Everybody punch that out, and I'm going to let somebody that's not me share it this time. I'm going to check it, though. Oh wow, that's more than I thought it was going to be. All right, so if you got a bigger number, okay, so I'm going to say it's that many grams, and then we may convert it to kilograms. All right. Hey, somebody who hasn't shared with us yet today. All right. Right here on the front row, tell me what you got. 171,927 grams, which then if we divide by 1,000, that would end up being 171.9 kilograms. Now they actually asked for grams, so we should report it in grams, and that's the number of grams. Okay, so you are absolutely correct. That's what I got as well. All right. Hey, we're going to do some practice. Thank you guys very much for listening and working with me this morning. All right, and have a great day.